Hey pre-calc students, welcome to today's lesson on the sum and difference identities in radians. So the first thing I want to remind you guys of is how the angles match up in terms of radians compared to degrees. Okay, so just a quick reminder, pi over 6 is the smallest reference angle we've been working with. That's equivalent to 30 degrees. Pi over 4 equals 45 degrees, and pi over 3 pi over 3 equals 60 degrees. Okay. Also, um, remember that the closest ones to the x-axis are the smallest reference angles. So pi over 6 equals 30 degrees. So the closest ones to the x-axis are your 30 reference angles of pi over 6, aka 30 degrees. Then come the ones that are a little bit farther away. Those are your reference angles of pi over 4, aka 45 degrees. And then last but not least, the ones that are farthest away have a reference angle of 60 degrees, aka pi over 3. Okay, so remember, you don't have to memorize these guys. You can use your rules of subtraction. For example, let's look at pi over 6, right? So everything in quadrant 1 is just 1 pi over 6, 1 pi over 4, 1 pi over 3. But when you're trying to find the equivalent one, let's say the one that's across this way, right? Then you know that it is 1 pi over 6 away from the x-axis. So the x-axis is 6 pi over 6. So if you use subtraction, 6 pi over 6 minus 1 pi over 6 will give you the 5 pi over 6. 6 pi over 6 plus 1 pi over 6 would give you the 7 pi over 6. Okay, so it's not like you have to memorize these guys. You can go ahead and figure them out by using your subtraction rule to the x-axis. Okay, so notice that these identities will be, we're repeating them from the last lesson. These will be provided. You don't have to memorize these, but you have to know how to use them. Okay, so we have a sum and difference of sine, cosine, and tangent. Okay, so really quickly, just so you know, most of the angles that we're going to be creating, or be given, sorry, will have a denominator of 12. Now, the reason they all have a denominator of 12 is because 12 is the lowest common denominator, is the LCD of pi over 6, pi over 4, and pi over 3. Okay? So you're going to be given angles that have a denominator of 12. So essentially what you need to do is you need to use the angles from the unit circle, okay, that are related to 30, 60, and 45. So all of these angles that have, right, look at the denominators, either it's a 3, 4, or 6. So the reference angles are pi over 3, pi over 4, pi over 6. And we need to kind of, in our minds, acknowledge that because we're going to be given angles with a denominator of 12, we need to know what the equivalent version of these angles are with a denominator of 12. So for example, pi over 6, if you multiply top and bottom by 2, that's equivalent to 2 pi over 12. Pi over 4, if you multiply it by 3, top and bottom, you get an equivalent of 3 pi over 12. Next, multiply by 4, you get 4 pi over 12. So essentially, you have to recognize that you can write out all these angles with the denominator of 12. So same with this one. Multiply top and bottom by 4 will give you 8 pi over 12. Multiply top and bottom by 3. Remember, your goal is to get a denominator of 12. So, but what you do to the bottom, you have to do to the top. So multiply by 3, you get 9 pi over 12. This would be 10 pi over 12. And you can even keep going, right? So multiply 6 by 2, do it to the top as well. 14 pi over 12, 15 pi over 12. 16 pi over 12, etc., etc. Okay? So we're going to be using these to help us create combinations of the given angles with a denominator of 12. Okay, so we need to create either a sum or difference of special angles. So again, all of the ones that are related to pi over 6, pi over 4, and pi over 3. Note it, remember that we changed them all to 12, denominators of 12. So take a minute to look at all the new angles that we converted to 12s and come up with a combination of creating 17 pi over 12 for number 1, negative 5 pi over 12 for number 2, and 19 pi over 12 to create number 3. Go ahead and pause the video now and create those combinations, and then push play when you're ready to check. Okay, so there are infinitely many correct answers here. For example, you can use 15 pi over 12 plus 2 pi over 12. That creates 17 pi over 12. I remember someone in class said 21 pi over 12 minus 4 pi over 12. That would be 17 pi over 12. And there's different combinations, so you can use addition or subtraction. Okay, for negative 5 pi over 12, I came up with 3 pi over 12 minus 8. But that's not the only combination. Okay. 19 pi over 12, you can create by using 15 pi over 12. And 4 pi over 12. Again, these are just examples, guys. Okay, so you just need one combination that works. Now notice that we changed all the angles in the unit circle to have a denominator of 12 for those purposes, right? To be able to come up with 17 pi over 12 for number 1, negative 5 pi over 12 for number 2, and 19 pi over 12. But those angles, right, with a denominator of 12 correspond to an angle that has a reference angle of pi over 6, pi over 4, pi over 3. So you're going to need to know that when you start evaluating or simplifying. Okay, so it says use the sum or difference identities to find the exact value of each. Use angles that are related to those in special triangles. Okay, so we've got sine of 13 pi over 12. So you just need one combination of angles with a denominator of 12 that will give you 13. So I chose 9 pi over 12 plus 4 pi over 12. Okay, and remember 9 pi over 12 plus 4 pi over 12 is 13 pi over 12. Now, if I'm going to be using my special triangles, remember those only use pi over 6s, pi over 3s, or pi over 4. So what you need to do is you need to ask yourself, how can I reduce these so that I get either a reference angle of pi over 6, pi over 4, or pi over 3? So 9 pi over 12 reduces to 3 pi over 4. Okay, so you can reduce by 3. And then 4 pi over 12 reduces to 1 pi over 3. So now we've written them with denominators that match the special triangles we've been working with. Okay, so from here you follow the pattern given to you in the identities. This is a sum for sine. So we're going to be using this top pattern or top identity. So you're going to take the sine of the first angle times the cosine of the second angle. Then you're going to add the cosine of the first angle and the sine of the second angle. Now, one of the things that we did in the previous lesson that I strongly recommend is writing yourself a little note about what quadrant these angles are in. So 3 pi over 4 is in quadrant 2 and pi over 3 is in quadrant 1. That'll just help you remember whether you're going to use a positive or a negative depending on whether they want sine or cosine. Okay, so sine of 3 pi over 4, that means you're going to use this triangle, reference angle of pi over 4, whatever the denominator is, right? So it's 3 pi over 4, that tells you which triangle you're going to use. So sine is opposite over hypotenuse, so in this case it's going to be 1 over root 2, which rationalizes to root 2 over 2. Cosine of pi over 3 is 1/2, so that would have up here, right guys? Pi over 3 adjacent over hypotenuse would give you 1/2. You're going to add that with cosine of 3 pi over 4. Remember that 3 pi over 4 is in quadrant 2 and cosine is negative in quadrant 2. Sine of pi over 3 is root 3 over 2. And then you simplify the same way that we practiced on the previous lesson. If the denominators are the same, fourths plus fourths are still fourths. You can combine the two numerators in one single fraction. You just can't subtract, unlike roots. So I can't actually subtract root 2 minus root 6. You got to keep them separate. So tangent of negative pi over 12. We're going to create a combination, oopsies, of how to write negative 1 pi over 12 using my twelfths. So you don't need to get crazy with it, right? You can just use the ones that you've been given. So you can use anything in quadrant 1 pretty much, right, to get a negative 1 pi over 2. So I don't know why, but my brain went to 3 pi over 12 minus 4 pi, but you could have easily done 2 minus 3, right? 2 pi over 12 minus 3 pi over 12. I can't really explain why my brain went to 3 and 4. But again, you could have also used 2 pi over 12 minus 3 pi over 12. Now remember, we converted some of the angles to 12s just to help us answer and split up the combination of the given angle, which was negative 1 pi over 12. But in order for me to actually find the answers, we need to reduce those angles. So 3 pi over 12 reduces to 1/4, and 4 pi over 12 reduces to 1/3. Okay, so now I'm going to follow the pattern for the subtraction or difference of tangent. So this time I'm going to be using difference of tangent, which is the last identity in the given choices. And here we go. So tangent of pi over 4 minus tangent of pi over 3, all divided by 1 minus tangent of pi over 4 times tangent of pi over 3. Okay, so remember we're using the reference angles given. So these are both in quadrant 1 and they're their own reference angles. So pi over 4 means you're going to use a reference angle of pi over 4. Pi over 3 means you're going to use a reference angle of pi over 3. The nice thing, like I said, they're in quadrant 1, so you don't have to worry about any of the signs being negative. So use your special triangles, find the tangent of pi over 4, tangent of pi over 3, etc., and fill in the pattern. Go ahead and pause the video right now and push play when you're ready. Okay. So you've got tangent of pi over 4 is 1. Tangent of pi over 3 is, let's see, tangent of pi over 3. Opposite over adjacent, that's root 3. And I just realized the pattern, I have it wrong. It should be a plus right here. Okay. And then 1 plus tangent of pi over 4 times tangent of pi over 3. So your final answer is going to be 1 minus root 3 and 1 plus root 3. Now remember, there are different combinations of getting of how to get negative 1 pi over 12. So if your answer ever looks different than mine and you want to see if you did it right, just type in your answer in your calculator, obtain a decimal answer, and see if it matches the answer to tangent of negative 1 pi over 12. So let me say that again. So the original problem asked for the tangent of negative 1 pi over 12. If you put that in the calculator, it should have the same decimal value as the answer you get when you do the algebra. All right, guys, as always, if you need any help, feel free to send me a message or email me, and I'll be happy to help. Have a good day.